Hi, students. Welcome to online classes. So today lesson is 4.5, prove trigonometric identities. So some identities that you already need to know is Pythagorean theorem. Sine power 2x plus cosine power 2x is 1. I will explain on that a little bit. Quotient identity, tan x is sine x over cosine x. Reciprocal identity, cosecant is 1 over sine x and secant is 1 over cosine x. Cotan is 1 over tan. As you see, the reciprocal of the trigonometric ratios is listed. Compound angle formula, we did talk about that in another class. Sine of angle x plus y is equal to sine x cosine y plus sine y cosine x. So here, if this is positive, you will have positive. But if you have negative, right, you'll get negative here. So here cosine x plus y is equal to cosine x, cosine y minus sine x sine y. Again, if this is plus, you get minus here. But if this is minus, you get plus here. So I want to talk to you about this identity a little bit. As you know, this is my unit circle. So a point on that is what? X and y. The corresponding angle here is theta. So you know from here to here is x value, and from here to here is what? Y value. If I want to say what is sine x, sine of theta is equal to what? Y over 1 is a unit circle. It's going to be y, and cosine theta is equal to adjacent over hypotenuse, so it's equal to x. Tan theta is equal to what? Opposite over adjacent. It's going to be y over x. So that's going to be enough for me. So looking at that, this is a right angle triangle. For right angle triangle, I can write it x power 2, the square root of the legs, equal to hypotenuse power 2. So 1 power 2 is going to be 1. So x to the power of 2 plus y to the power of 2 is 1 for this right angle triangle. Now, instead of the x, what did I have? Cosine x, right? So cosine of the x power 2. Here, instead of the x, I put cosine x. And instead of y, I put what? Sine power 2. Off again, sorry, I need to put that in a theta. The angle is theta, is equal 1. Again, sine x is y, cosine of the theta is x, sine theta is y. So instead of the x, I put cosine theta. Instead of the y, I put sine theta. So as you see, this is my first identity, Pythagorean. So always cosine power 2 of an angle plus cosine power 2 of the same angle is equal to 1. So as you see here, tan is y over x. So instead of the y, I can put what? Of course, sine theta. And instead of the x, I put cosine theta. See? I proved the second identity. Tan of an angle is equal to sine of angle over cosine of the angle. So for the reciprocal identities, you need to know that cosecant is 1 over sine. For a trick for you to memorize, CS, SC. So the opposite letters come together. And cotan, you need to know is reciprocal of what? Tan. Also, compound angle formula I did talk about. So we're good to prove trigonometric identities. So this is my first question I put it to the board. So tan theta is equal to sine theta plus plus sine power 2 theta divided by cosine theta 1 plus sine theta. So how do I do that? So I divide my board into the two sections. So left side and the right side. So this is left side and this is right side. What do I have on the left side? Tan theta. And what do I have on the right side? I just copy it down. Sine theta plus sine power 2 theta divided by cosine theta 1 plus sine theta. I need to prove that the right side is equal to the left side. So what do you think? Here seems very simple. It is the tan theta is sine theta over cosine theta as we did and show it. So here I need to simplify that, right? So in numerator I can factor out sine theta. Sine theta factoring out is 1 plus sine theta divided by 1 plus sine theta. As you see, these two brackets canceling each other. I forgot the cosine theta here, guys. Just cosine and copy it down. So as you see, I got sine theta over cosine theta. See that the right side and the left side is the same. So left side here equal to right side. So I checked that they are equal. So get an overall of this question. So that was example 1. I want to prove another example. A little more work toward that. So again, I have a right side and a left side for this. Sine power 2 minus cosine power 2 minus tan power 2 equal to, in the numerator, 2 sine power 2 theta minus 2 sine power 4 theta minus 1 divided by 1 minus sine power 2. As you see on one side, on this side, guys, all we have sine, and here we have mixture of the sine, cosine, and tan. So a little bit side here, you need to know that sine power 2x 2 theta is equal to what? Plus, maybe I just wrote down, cosine power 2 theta is equal to 1. Therefore, cosine power 2 theta, I can convert it to the sine power 2. How? Just move this one to the other side. So I need to use this to convert my cosine to sine. Why I want to do that? Because at the other side, everything is sine. So I want to start with left side. Left side, I want to prove that my left side, I just put the line here, see? And the right side here, I want to prove that the left side is equal to right side. I need to start with that. So sine power 2 theta sine power 2 theta minus cosine power 2 theta minus tan power 2 theta. So instead of the sine power 2 theta, I just keep it the same because at the other side is everything sine. Now instead of the cosine theta, I put what? 1 minus sine power 2 theta. I want to convert it to that. And here I know tan is sine over cosine, right? I know it's a power 2, so I have to put the power 2 here as well. See, I need to convert a cosine power 2 to sine power 2 by replacing that. Sine power 2 theta minus 1. Sine power 2 theta. So instead of cosine power 2 theta, I put 1 minus sine power 2 theta. So I need to take a common denominator. As you see, the denominator here is 1, denominator here is 1, so common denominator is going to be 1 minus sine power 2 theta. I need to multiply 1 minus sine power 2 theta to the numerator and denominator. So sine power 2 theta, 1 minus sine power 2 theta minus 1 minus sine power 2 theta. Multiply by 1 minus sine power 2, they become power 2, of course. And this one I don't need to multiply by anything, it's already, the denominator is there. So denominator is 1 minus sine power 2 theta. So I need to simplify my numerator. I multiply that in sine power 2 theta minus sine power 4 theta. Here, if I do that, it's going to be minus 1. Twice of this multiplied by that is going to be plus. I know it's minus, but you have a negative beside that. So sine power 2 theta. And this one power 4. So you have a negative behind that. So it's going to be sine power 4 theta minus sine power 2 theta. Now I have lots of like terms in numerator that I need to simplify. See, here is sine power 2, 2 sine power 2, and negative. So this one is canceled with that one. I just did that quickly. Sine power 4 negative and sine power 4 negative. So what I write is 2 sine power 2 theta minus 2 sine power 4 theta minus 1 divided by 1 minus sine power 2 theta. Okay, see that this is my left side. I simplify. And is it the same as the right side? Yes, as you see the right side, I don't want to just write it again, but I started from the left side, prove it to the right side. So therefore I can say that right side is equal to left side, and I proved that. So left side is equal to right side, and I proved this trigonometric identities. Now, my student, I want you to do these questions. First one, secant x minus tan x sine x is 1 over secant x. Question number 2, 1 plus cosine x over sine x equal to cosecant x plus cotan x. Question number 3, secant theta multiplied by sine theta divided by tan theta, cotan theta is equal to sine power 2 theta. Number 4, secant theta divided by cosine theta minus tan theta over cotan theta is equal to 1. So for this question, do it and send it to me. Thank you.